Alright, so today we're going to be talking about now using something called the rational root theorem to find zeros of a polynomial. So this is when you're given a polynomial that's not factored and you can't find the zeros. So this is another method to narrow down the search for these roots, zeros, x-intercepts, those mean all the same thing, of polynomials that are not factored. That's what the rational root theorem is. Alright, we're going to do two examples here. This is the wrong one. Let's see. And there are steps here that you guys should copy down, definitely in your notes. So the first one that we're going to work on together is this one. Alright, so here are these steps. There are 5 steps. There are 2 below that you can't see yet. So the first thing you want to do is find factors of the constant term, and they're labeling it as the variable of p. The constant term is the number at the very end. So whatever number is all by himself without a variable, that's the p. So we want to figure out, okay, what are the factors for 8? What multiplies to give me 8? So we know 1 and 8. And I'm putting plus and minus because I could have a combination of both positives or both negative to multiply to get 8. And I could also have 2 and 4. Number 2, step 2, is finding the factors of the leading coefficient, and they're calling it q. And the leading coefficient is the one with the highest exponent, which is right here, which is to the 3rd. And this variable, this coefficient here in front, is a 1. So the q is 1. What are the factors of 1? 1 times 1. Now, to get all the possible zeros using this rational root theorem is we're going to divide now p divided by q. So you're taking all your p's and dividing it by q, which is the 1. So if I take 1 divided by 1, I get 1. I take 8 divided by 1, I get plus or minus 8. 2 divided by 1, plus or minus 2. 4 divided by 1, plus or minus 4. So right here now I have 2, 4, 6, 8. 8 possible numbers that could be my zeros, my roots, and my x-intercepts. Now, how are we going to figure out which of these 8 are zeros or roots? We are going to now do what we have here below. So we're going to be using synthetic division to find which divides, and I get a remainder of 0. If you don't get a remainder of 0 when you choose one of those 8 numbers, then that means it's not a factor of this polynomial. So I'm going to rewrite the numbers here. We had 1 and 8, 2 and 4. Alright, so let's refresh our memory about synthetic division. So I need to set up my coefficients of my polynomial. So this was my polynomial. I'm going to rewrite it down here. Alright, so I have the imaginary 1. I got negative 3, negative 6, and 8. And then I make my little house here. Alright, now outside here is I'm going to choose a number that I think could work. Alright, I'm going to choose, let's say I'm going to choose 8. Positive 8. Put it on the outside. Remember, you're always bringing down that first term, first number here. Bringing down the 1. What was the process again? 1 times 8 is 8. Put it in that next spot there. Add these 2 up. Negative 3 plus 8 is 5. Multiply 8 times 5 is 40. Add those 2 up. Negative 6 plus 40 is 34. So I'm already going to stop because 34 times 8 is 32, 32, 24, and 3. I think that's 272. This thing here is so large. This is not a remainder of 0. So we know 8 is not a possible 0, root, or x-intercept for this. So you have to keep going by trial and error to see which one gives you a remainder of 0. Alright, let's try 1. So I'm going to set this up again, putting our coefficients, 1, negative 3, negative 6, 8. Let's try 1. So we're going to always bring down that first number here. 1 times 1 is 1. Add those up. Negative 2. Negative 2 times 1 is negative 2. Negative 6 plus negative 2 is negative 8. Negative 8 times 1 is negative 8. 8 plus negative 8 is 0. So this is the one that is a possible root here, the number 1. So what do I do now? So we're going now to step 5 because I figured out which one of those work. You only need one. And now what I'm going to do is take what's here and write it as a polynomial. So remember how we did that for synthetic division? We would take a look at what we started with, which was x to the third. That means we are dividing, so we're going to go 1 less. So that means this is 1x squared minus 2x minus 8. Now, this was a 0, the number 1. So if I wanted to know what this was before I got it to be 1, and we talked about this working backwards in a previous video, it would have been x minus 1. Because if I make this equal to 0 and solve it, I would get the number 1. So I got a possible 0 here. Now, you see what's left? We should be able to factor that. So how do we factor this trinomial? We want the factors of negative 8 that multiply to give me negative 2. So that would be 4 times 2. Which one's going to have the negative? The 4 is, and that's plus. And this comes down. So this is my factored form of that x cubed minus 3x squared minus 6x plus 8. And then I would go ahead and graph this. So if I wanted to do a quick little graph of this, right? Right, what are my zeros here? We got it to be x minus 1 is 0, so this is 1. X minus 4 is 0, this is 4. And this one is negative 2. Alright, so let's plot these 3 points. We got our negative 2. We got our 1. 2, 3. We got our 4. What is the degree of this polynomial? That also was from the other video. It's a degree 3. What's the end behavior look like for this graph? It's an odd degree and it's a positive, so that means it's down and up, down and up. What's the multiplicity for all of these? These all have a power of 1. So all these multiplicities are 1. Odd, so that means they're going to cross all of these. Cross. So I'm going to cross through the negative 2, cross through the 1, cross through the 4, and that's what the sketch of this polynomial would look like. All right, let's try one more example.
Oh my God. What fuck you?
Yeah, they hear you on the video. Okay. Alright, here's this one here. We're going to use the rational root theorem to figure out all the possible zeros, factor it, and graph it. Alright, so it's 2x cubed plus 11x squared minus 7x minus 6. Which one was the p? Which one was the q? Here was our p. Here was our q. Alright, so step 1 says to find all your factors of p. So what multiplies to give me 6? 2 times 3. 1 times 6. Alright, 2 factors of the q term, which is 2. So plus or minus 1 times 2. Step 3 says to divide all those possible factors. So here we have plenty. So let's take a look here. We have 2 divided by 1. We have 2 divided by 2. 3 divided by 1. 3 divided by 2. We have 1 divided by 1, which is 1, which I already have, so I'm not going to repeat it. 1 divided by 2. We have 6 divided by 1. And then we have 6 divided by 2, which is 3, which is already what I have. So I have all these possible things that could be possible zeros. 2, 4, 6, 8, 10, 12 of them. Alright, so we have to now go to step 4 and do our synthetic division to see which one works. Alright, so let us write down our coefficients here. 2, 11, negative 7, negative 6, Alright, I'm going to try 1. Let's bring down the first term, 2. 2 times 1 is 2. We add that together to get 13. 13 times 1 is 13. Add these together to get 6. 6 times 1 is 6. Alright, so I was lucky there. I figured out what is a possible 0 on my first try. So, how do I write this? So remember, we started with cubed, so that means this term is going to be 2x squared plus 13x plus 6. And now what was this? Because we know it's a 0, it was x minus 1, because we got it to be 1 when I solved it. Now, we need to now factor this thing here. So I'm going to move this down. Alright, so let's see if you guys remember how to factor something with a 2 in front of it. It's a little bit more difficult because it's not just x squared. Alright, so instead of it being x times x, it's going to be 2x times x. This is coming down. So you need to figure out factors of 6. It's not going to add up to 13 because of the 2. So we got to figure out if this works or if 6 and 1 work. They're both going to be pluses. You could refoil it out if you like, or multiply the inner and the outer terms to see if it works. I'm going to do that. This is 2x. This is 6x. When I add that together, I get 8x. So that's no good. Let's switch the position. Let's do 3 with 2. Multiply the inside, I get 3x. Multiply the outside, I get 4x. That's 7x. So it looks like 3 and 2 are no good. Alright, let's try 1 and 6. 6 and 1. 1 times x is 1x. 6 times 2x is 12x. That's better. So when I add that up, I get 13x, which is here. So this is the correct factored form, the 2x squared plus 13x plus 6. Alright, now we have to go ahead and actually graph it with the zeros. So this one here is 1. 2x plus 1. Subtract the 1. Divide by the 2. I get negative 1/2. And this one here, I get it to be negative 6. What are the multiplicities for all of these? They all are raised to the first. So all these multiplicities are 1. So that means they're going to cross. What is the degree of this polynomial? It's a degree 3 from the very beginning. That was the highest power. And it's a positive coefficient, so that means that end behavior is down and up. Alright, so let's make our little x and y. Let's go ahead and plot these three. 1, negative 1/2, negative 6. 1, 2, 3, 4, 5, 6. This is negative 6. This is negative 1/2. And here is 1. And end behavior is down and up. They're all crossing, so I'm going to start down and go and cross through all of them. So there is a quick sketch of that one.